Hello, my name's Jade. I've worked on, as Mike said, I'm a senior software engineer at Theta Lake. I've previously worked on 8 different Rails apps as part of 4 different Rails systems, totally different architectures, totally different products, but what they've had in common is scaling challenges. So, first up, have you ever had a big spike in user traffic come into your system? Has your Rails app ever started slowing down or shedding requests to the point where it looks like it's actually down? Or maybe, instead of user traffic, you've had a different kind of problem, in that whatever data source you ingest grows to the point where it's going to take just too long to ingest all into your system at the regular interval that you need to. Then, if any of those ring true, this talk will be useful for you. So, the last time I spoke at RubyConf in Denver, one of the questions was about load testing for user traffic, and I recommended a tool some former coworkers had written for shadowing or replaying real requests against a system. The subsequent year, I moved to Theta Lake. We are a fintech, more specifically regulatory compliance, and since 2022, a few engineers have been doing performance testing on a replica of our production system. And earlier this year, I was asked to join in on this. So to give an overview, this is basically a cross-team project with people from the ingestion team, operations team, and my team working on the customer-facing app, Rails team, and it's led by our CTO, Rich. This talk is about a methodology for replicating a production system, then seeing how it performs when we push more data into it than we currently see. You might ask yourself, why? Well, the point of the performance and scalability testing we're carrying out is to demonstrate the maximum performance and throughput of our system when balanced against operating at a reasonable cost. So you could horizontally scale out further. We're just looking to balance operational cost and throughput. There's the old quote about premature optimization, which I'm sure many of you will know, and I would agree that if you don't need to do this sort of thing, then don't, maybe. But what we're trying to do here is, given what we know, what we've been told, and where our ingestion is in terms of scale at the moment, we're trying to see ahead a little bit into the future in order to find bottlenecks in our system. Then we can both demonstrate how scalable it is at the moment and also find limiting factors that we can then look to mitigate. So my hope is, if you're on a team that is starting to see scaling challenges, then you'll be able to go back to your team and apply this. Could be a big hope, but the idea is you want to do this before either your server costs soar out of control or your entire system is about to start acting like it's down or actually go down. So yeah, today I'm going to present our methodology for replicating our system for the purpose of load testing. Right, so bit of background. For this sort of thing, a lot of the tooling and resources that you'll hear about are for looking at the performance of big systems designed by and for absolutely massive companies operating at truly massive scale, so Netflix, Shopify. And a lot of the work, including the literal book on the subject, has been done by Gren and Greg, who is at Netflix. The issue is in smaller companies where you don't have that large team, you may have different constraints. And also, as well as having people's time limited, you might not want to operate a fake version of your system all the time because it would simply be too expensive. Like, why would you do that? You may also have some or a lot of PII, personal identifiable information, that you have to remove before it goes into an external logging tool. And specifically to us, you cannot use production data in any form, even anonymized. The problem is, when you're operating at some kind of scale, just your Rails app alone, like your single monolith, isn't often going to be your entire system. So you could locally optimize performance in it. You could see someone's PR and say, oh, I think that could be a bit faster there. But you could do the classics. You could just switch out malloc for gmalloc, put an index somewhere in your database where you need it. But this might not even be where the bottlenecks are, so that could, in that case, be wasted work. So, in short, we want to replicate our entire system on real infrastructure with real logging, and then load test against that. I personally think this is really cool, and I've not actually seen it before, so I'm going to walk you through how we do it. So I just wanted to clarify a bit of terminology. This is very directly from Brendan Gregg's book that I put a few slides ago. So few important points. So throughput is defined as the rate of work performed. Workload is the input to the system or the load you're applying to that system. Response time is the time for an operation to complete, both comprising of wait time and actual service time. And then utilization has two definitions. For resources servicing requests, like servers, how busy a resource was, and for resources that provide storage, the capacity consumed. So, for example, memory utilization. Then, probably quite an important one for this talk, bottleneck is a resource that limits the performance of the system, like a limiting factor, and you're aiming to identify and remove systemic bottlenecks. Okay, so this is a high-level diagram of our system and what it does, and I've highlighted some fairly typical areas of a system in my experience. So data ingestion, your pipeline, and then Rails, Scikit, all the usual, maybe an API, maybe not. And here, our data ingestion has things like it's got a pipeline, leads into a pipeline for content analysis, and I'm not going to go into great detail of that. My team's part of the system is the Rails, Scikit, all the usual. And then this is an architecture diagram, so we'll have various integrations like Zoom, Slack, they feed into a system called the integrator, that feeds into the ingester, through to the pipeline, through to Portal, which is the Rails app, and then the API kind of feeds into quite a few of those. I've seen similar architectures or heard about them, and a fairly common thing I've seen is for there to be differences in how you do data ingestion. I've seen a few places where the strategy is to write, or in some cases actually rewrite your data ingestion service in a language other than Ruby, and so maybe Clojure, maybe Golang. The other month I actually heard about a web hosting platform who'd also decided to write, like us, their data ingestion service in Golang, and that gets data into database, and then it eventually gets it into a form where a Rails monolith reads it. But interestingly, that team are actually going to move back to Ruby because of team changes, so it's therefore easier for that team to maintain their data ingestion service. Okay. So I've covered when it will help to load test your system. Let's get into details. So firstly, we want to replicate the existing system. Assuming you want to repeat this process, perform several load tests, not running just constantly, and also not pay to have that infra up all of the time, you're going to need a way to build up and tear down that infrastructure. So we use Terraform. Many of you will be familiar. In case anyone isn't, Terraform is infrastructure as code. If you've ever dug around in an AWS console looking for some kind of configuration setting, you'll understand why that's a useful tool. In my experience, some teams that are on Heroku or AWS may already be using it, and you might not. You might have plans to move on to it. Benefits here are for performance testing. Like I said, you want to be able to build up that infrastructure in the same way and then tear it down between tests, so you're not leaving it idle and paying for that capacity. And you want roughly the same setup as production, and you want to bring it up and tear it, and as I said, tear it down in a repeatable way, and that is what Terraform was very useful for. Next thing is you want to think about how work arrives in our system. So systems I've worked on have had two typical ways, pretty standard, either user traffic or some kind of data ingestion service. Okay, then the third thing you want to think about for the purposes of load testing is how can we then artificially push work into this performance testing system. So there are, for user traffic, I'm aware of two companies that have looked at doing request replays or shadow requesting. So you're capturing real production requests, removing the PII so it doesn't go all to your logging, and then replaying those against your system. Companies I've heard of who are doing this have actually open sourced their tools. So one is Carwow and Umbra, and the other is Love Holidays and a tool called Ripley. which I recently saw a talk about, actually, so I was like, oh, coincidence. In our case, because our customers are in regulated industries, it is not appropriate at all to use their real data. So instead, what we use is a Go tool my colleague David, who's on the ingestion team, wrote to generate some fake data to approximate present-day workload. And then from that, we do 10x, 100x, 1000x, etc. So the sort of things that are coming into the system are emails, chats, Zoom calls, etc., etc. So we're going to push fake versions of those through the ingestion service. So foundational work on our tool for this generation and pushing fake data into our system actually happened before I got involved. So I asked David about his approach for reflecting real traffic coming in. According to him, the approach he took was to push traffic at certain volumes that correspond to what we were already seeing, and seeing what we would need to process that in terms of resources, servers, etc. And then we could look at the sort of 24 average rate across a workday, check the difference, and then use that to check the difference between that and the kind of peak load demand requirement for resources, and then work out from that how many resources we needed for that. So we used volumes of anticipated customer data and allowed some extra for growth, and used that to get a kind of average rate. And then once we hit that, then we would have at most 24 hours latency in processing data coming in, all of it kind of normalized out. With the rate of processing per machine, or maybe N machines, we could look at production data centers, the heaviest used ones, and look at the effective rate of the typical busiest hour, and then see how that differed from the 24-hour rate. So that would, again, that's kind of deciding how many resources that we need to process extra workload coming in a satisfactory time. And this diagram is just showing 24 hours of ingestion for a production server. So average rate here was about 83,000 records processed per hour. And the idea here is just to get to a message, get to a processor record through in a reasonable amount of time. So, finally, measuring results. Before I read computer science, read biology, which covered the scientific method, how you generate a hypothesis, design an experiment, test it, and then analyze your results to see if you're correct or not. Pretty standard stuff. But then we also had a really cool lecture from one of our immunology lecturers, Dan Davis, about how his research group was sort of flipping that by gathering tons of data and then sharing the data itself with the wider scientific community. So both his research group and also other teams could analyze it, draw conclusions, and then publish from that. So we're partway there in that we're gathering tons of data in our standard logging. And then from that, so like I said, we have the same logging that we do in a production system. And from that, we can also therefore look at CPU utilization, RAM, and also individual log lines from each component in the system. So I'm going to skip over looking for absence of errors, because that's kind of tends to be early on in a load test, where you might have needed to switch something off external, like sending emails, and that might be quite specific to your system. So this is, this is an example load test, and we wanted to look at the part of the system that routes records through to workflow. So the idea is to assign to an individual for review. And we were putting 240K records through and looking for no errors, total time to process all of those 240K records, and how long each individual record took to be processed. And this is what it looked like over time. This is the individual time per record processed, and that was working out to about 2.5 seconds per record to go through that workflow. So then we have logging as well through out that code path, so we can break down where the time is being spent. So from most to least time spent, we were assigning those records to a workflow, and then a lot of time preparing, less time, 31% to set up a new record, then 8% to enter the actual workflow process, and then everything from there was 4% of the time or less. So we weren't super concerned about that. Okay, so that's a kind of a gist of one performance test. This is now a full system performance test I'm going to walk you through. So you do not need to read all this. The key points are, this is a full systems performance test that we carried out. It was across 5 days, ingesting 190,000 fake chat records per hour, 634K fake email records per hour, and intentionally exercising the identity matching part of the code base. So on the Rails side, a very important area is how we recognize new participants from Zoom meetings that we ingest and make sure that we're not constantly saying, oh, Jade with this email address is one person and Jade with this email address is another person. But you have to have a couple of things to match on. There are going to be things that will identify as clearly the same person, like combination of name and number or name and employee record, for example. So to artificially stress test this part of the system, my team already had something to generate an arbitrary number of meeting participants written by our lead, and I wrote a rake task that was to generate pairs of participants that would be recognized as the same person. So say 100,000, and then our Rails app is going to realize that those are actually 50,000 individuals, just with very slightly different details. Then, when we're pushing fake Zoom meetings into the system in the overall systems test, it's going to hit this code path for identity matching, and then we can see how that handles that increased throughput. Okay, so this was really cool. So 2 days into the test, I mentioned it was a 5-day test. Just from force of habit, from doing daytime like site reliability support rotations a couple of jobs ago, I checked the Sidekick queues about 11 o'clock UK time, and they were really, really backing up. So just want to emphasize this is not a production system. This is a performance testing system, so we're fine. The workflow Sidekick jobs were taking excessive amounts of time to complete, and to be more specific, the mean time of seconds to complete was suddenly the exact same as the P99.9. So the other issue, the same issue really, we were looking at latency of 6.5 hours for one of our Sidekick queues, which is nothing like our normal latency. So obviously it felt a bit high. And at some point in the night, the database connection count had doubled from about 500 to 1,000. And therefore, each of those workflow items was taking a lot more time to process. The actual time per record was still around 2.5 seconds, but they were waiting far, far, far longer in the queue than usual. So then, at midday UK time, so about an hour later, jobs actually started failing, and there was a massive spike in the classic active record database connection error, which I'm sure many of you will have seen before. So reasonably obvious if you've seen this yourself, this is not good. This could be an incident, depends, but obviously in a production system. And what was happening here was the database server was just, the resource was just getting totally exhausted, and that just led to database, keep trying to open a database connection, keep getting rejected, job fails, goes around again, and it just keeps on backing up the queue like that. So that 500 database connections number actually used to be Heroku's limit on Postgres database connections, and at the end I'll share a reference from them on rationale behind that. So there's ways that you can handle this. In this test, we just scaled up the database, and that worked perfectly fine. So what I thought was really cool about this was we got a preview of what could be a real production incident before it ever actually happened in production. So we got to mitigate and prevent it ever actually happening for real. So, sharing data, why bother? I've talked about the how, why, the sort of things you might find when load testing. I want to go back to what I said about sharing data and not just results. why would you bother? So you want to bring your team along with you. This was really an excuse to get Cubby on the slides again. And the idea is you're limited on time. Ideally, if you can share around the results from your logs, then everyone can pick up optimization work when there's time available. So what would be ideal? Share the data, in this case by sharing your logging results from each load test. So from what you learn in load test, you can do smaller scale controlled experiments. And I would basically just point you to Nate Berkopek's work, especially the DRM method, database Ruby memory. And I'd say both of these two books are the go-to resources for Rails performance optimization. This actually doesn't require a performance testing environment like I've described. Instead, you start by benchmarking locally and proving the worth and improvement of your performance PR, and then you do the same in production if you've got approval for the PR. What's kind of cool is that once you followed that process, you can also prove how your optimization will perform in a larger load test. This is something that we've done with a couple of my teammates' work, which has been really interesting. So then just going back to the point about premature optimization. I'd agree with anyone who's thinking about premature optimization being the root of all evil. The actual full quote is that there's no doubt the grail of efficiency leads to abuse. We waste enormous amounts of time thinking about or worrying about the speed of non-critical parts of our programs. And these attempts at efficiency actually have a strong negative impact when debugging and maintenance are considered. So we should forget about small efficiencies, since say about 97% of the time, premature optimization is the root of all evil. That's the full quote. So everything I've discussed in this talk is about ignoring the non-critical. So instead, to find bottlenecks in critical parts of your system so you can rectify them, preferably just before you need to. Summing up, using the methodology I've described, you can carry out large-scale measurements, share data and your insights from those tests with your wider engineering team, and you're using tools to anticipate problems rather than having to react to them when they happen and just cause panic. The idea is to anticipate multiples of your current scale and replicate your system with Terraform. Think about how the workload or traffic arrives into your system, whether that's user traffic or data ingestion, and then from that, load test and take measurements from a performance testing environment. And I've also walked you through a few example findings and thought about looking ahead, how you can share that with your team. So yeah, thank you for listening. I'll be around for questions afterwards.